in the types of reactions, we will take up the free radical substitution reaction. Free radical substitution reaction. This you can call it as a FSR type of the reaction, but however technically it is a substitution with radical. So, therefore, let us stick to this terminology. SR type of reactions means the main reaction is substitution, that is one group is entering, the other group is removed. It is a substitution with a radical. So, therefore, R is used for the radical. So, SR type of the reactions. Examples, all alkanes undergo this type of reactions. Main reaction of the alkane is free radical substitution reaction. An example, if a methane is treated with the chlorine gas, the reaction gives a methyl chloride. One hydrogen is being replaced with the one chlorine, and the hydrogen and chlorine is removed as HCl. So, net reaction is a one group replaced by the Cl, therefore, it is called a substitution, and it is observed that the Cl is coming as a free radical and entering into the molecule, therefore, it is called free radical substitution reaction. The reaction appears to be very simple, but it too has got some complications and attractive features also. One of the feature is the methane gas and the chlorine gas, if you mix together and keep it under the dark. So, one first condition is put it under the dark. That means no light energy, no heating energy, there is no reaction. So, both the gases, if you put it under the dark, so that means no light energy and also the heat energy, the reaction is not taking place. But the same mixture, when you put it under the bright sunlight, there is a formation of the 4 moles of HCl and the carbon, and huge amount of heat is liberated, and this heat is because of the liberation of sudden, and flame comes out and the carbon also burns, and explosion type of the reaction is observed. So, this is one extreme end, that is high reaction, and this is the other extreme, there is no reaction. But what is the ideal condition to give the reaction means, it is studied either the light energy, that means H mu, light energy if you want to use the UV light, or if you want to use thermal energy around 250 degrees centigrade is found to be suitable. Again, either of one only, first condition or second condition, do not use both, again it will become the higher reaction. So, either the UV light or 250 degrees centigrade if you use, the reaction is taking place and giving, that is the moderate condition. However, it has another feature also. Most of the reactions, what happens, let us say to complete the reaction 2 hours is required. After 1 hour, if the energy source, if it is not available, the reaction will become stop, and the almost 50% of the reaction will be left over. But this reaction is not like that. There is no source energy, no reaction, but once you give the, let us say, UV light, the reaction starts. If you sure that the reaction is already started, you can withdraw the UV light. That is the one special feature here. You can withdraw the UV light and the entire reaction takes place. However, time is required. You give enough time, but the light you need not to continue till the end of the reaction. That means the reaction has only starting problem. Once the reaction starts, whatever the amount of methane or chlorine you take, the total reaction automatically, that is, once it is started, the reaction leads to give the final product, total product is converted. However, the reaction in this case, because 3 more hydrogens are there, the methyl chloride further reacts with the same condition. If it is prevailed, you will get the CH2Cl2. Further reaction will give the CHCl3. Further reaction will give the CCl4. That is, all the hydrogens which are alkane type present in the compound, one after the one will get, and you will get finally the total chlorinated, or we can call perchlorinated the alkanes. In the case of 1 carbon, you will have 4 chlorine, that is carbon tetrachloride is formed. This is chloroform commonly formed, called, this is methylene chloride or monochloromethane, dichloromethane, trichloro, tetrachloromethane you can call, carbon tetrachloride or tetrachloromethane. So, this reaction is called conjugative reaction. That means a product formed once again reacts, finally product is formed. But this reaction, as I said, the reaction doesn't need the source of energy till the completion of the reaction. Just once you start, the whole amount what you have taken is going to react and gives the final product. How it is possible means there is a mechanism proposed called chain reaction. The chain reaction means actually one link to the other and so on. That is the meaning actually. Is this the chain reaction, that methyl chloride, that is methane to methyl chloride, methylene chloride? That is not the actual chain reaction. Every step, methane to methyl chloride is a chain reaction. Methyl chloride to methylene chloride has a mechanism. The mechanism is chain reaction. What exactly this chain reaction mechanism means? For the first step, the chlorine molecule needs some energy like UV light. Energy is required. It undergoes a breakage. It is an absorption of energy. So, bond is cleaved. And both the chlorine molecules are becoming into the chlorine molecule will become into the 2 chlorine free radicals. Let us call this is the first step of the reaction, not total reaction, a part of the reaction identify as a step. So, in this step energy is absorbed. So, definitely the potential energy of the 2 free radicals of this chlorine will be more than the chlorine molecule because energy is absorbed. So, the chlorine free radicals are now associated with some energy which are whose potential energy is more, stability will be less, highly reactive. All free radicals are considered to be highly reactive. Now, this the reactive Cl dot will react, will have a different chances, but initially a fresh methane is available. So, therefore, let us write the reaction. This chlorine dot is going to react with the methane. Even the bond breakage requires some energy and it is free radical, therefore, the bond breakage will be free radical, it is induced. Now, will it react with H dot or methyl means you have the 2 chances are there. One is reacting with H forming HCl and liberating the CH3 dot. The other one is it may react with methyl to get the methyl chloride and liberating the H dot. Both are possible, but the potential energy of this first one is less, or stability of the second one is not much. So, this is potential energy less and more stable. So, this will be taking place. Let us recognize this as the second step of the reaction. And now, in the second step, once again free radical is formed. When once the free radical is formed, it is highly unstable, it is bound to react with the or participate in the conjugative next step it is. So, CH3 dot is going to react now immediately. So, CH3 dot will react with what? It has a different sources. It may react with the Cl dot directly to get a methyl chloride, where from Cl dot means in the previous case we got, but initially the methane is more, therefore, the chlorine dot will have a chance to react with methane. When once the methyl dot comes, more chlorine will be available. So, therefore, This type of reaction, if CH3 dot reacting with the chlorine, will be the more possible to get the methyl chloride and the Cl dot. That is, this is the third step of the reaction. Now here the one is unique type because the molecule becoming into the two free radicals. Now recognize the types of reactions here. Two dots reacting into molecule, this is another type. You can have a CH3 dot reacting with the another CH3 dot, getting the ethane molecule even. Okay, similarly, the CH3 dot may have a chance of reacting with the either with the Cl dot or with the CH3 or with the, you can have another chance that two Cls also may react to give the Cl2 molecule. So these are all just possibilities of the reaction. So let us designate this as a fourth type, and this is the fifth type, this is the sixth type of reaction. And these six types of reactions, if you commonize, there can be further grouped up. The first one is unique, that is molecule becoming into two free radicals nowhere you find, and this is the starting reaction. So if this takes place, then only all the steps will take place. Therefore, I call this as a chain initiation. Chain initiation. This step is called chain initiation step. And the 2 and 3 have got some similarity. What is that? A free radical with a molecule gives a molecule and free radical. A free radical and a molecule and free. That means this side one molecule free radical, that side also one molecule free radical. So in the product side, if one free radical is there, it is bound to react with one more. So what we think is, after 1, 2 takes place, after 2, 3 takes place, after 3 we'll think 4 will take place. No. After 2, 3 takes place, no doubt. But 3 slides into the second reaction. That means in the third reaction, what you get Cl dot will start the again second reaction. So second after third, a loop type of reaction goes on till the whole methane or whole chlorine converts into the product. So the 2 and 3 are called repetitive units, and both together we recognize as the same type. So this chain initiation is the first type, and the 2 and 3 belongs to the same type. We call it as a chain propagation. Chain propagation. And the 4, 5 and also the 6 together is called the third type of reaction, that is called chain termination. What is termination? Termination means the reaction is coming to end. See the feature, two free radicals join, becomes into molecule. No free radical is associated in the products. In the products, no free radical means there is no further scope for the reaction. In the first one, 2 free radicals are formed. Second and third, 1 free radical is formed. One molecule consumed, 1 free radical is generated. That will come and start 3. In the 3 dot comes, again start 2. So 2, 3, 2, 3 will be going on giving the reactions. So this type of reactions are called chain propagation reactions. Chain propagation reaction. That means the reaction goes on more and more and more with any extra energy. Energy is consumed only in the first step, that is chain initiation. The second, third, that is in the chain propagation, it doesn't require any extra energy because the energy associated with the free radicals are breaking the new bonds, and again free radical is formed, that is breaking the that is stable bonds and all that. So therefore the chain propagation is totally free of consumption of any extra energy. So the entire reaction takes place if first step takes place. That's why only initially we need energy, not that to complete the reaction energy is not required. All this 1, 2, 3, 4, 5, 6 are called a possible type of the steps. However, what is the actual the steps of the reaction involved means methane is not going to give methyl chloride directly. What it becomes is, it becomes into CH3 dot. So, this is the step 1 in fact. In the step 1, an intermediate species is formed. Intermediate species. This will react with either with a Cl dot or a fresh chlorine, will give the final product. So, this is called step 2. So, there are only actually 2 steps are there. So, first hydrogen is gone and the Cl is coming in. So, after the removal of the H, what you get is called intermediate. This is like the in HCl addition to the ethylene or in the benzene substitution. All the reactions also having the only 2 steps. These are not the 6 are not the steps for the reaction of a methane to methyl chloride. These are all types of reactions may be possible, in which the initiation, propagation, terminations types of steps are involved. All this the type of mechanism together we call it as a chain reaction mechanism. In this reaction, what is the intermediate species means? CH3 dot. Once you know this CH3 dot formation mechanism, we are going to answer. For example, instead of methane, if you take propane, you have a chance of getting 1 chloro, 2 chloro. It shows that the 2 chloro will become the always will be produced in the major quantity. Why it is so means we should know the mechanism of the such reaction. So, it is a free radical substitution goes through the CH3 or the if you take propane, N-propyl and 2-propyl or isopropyl will be the intermediate species, and of which isopropyl is the more stable one. That is why the product is more formed. That will take details later, but unless you have a mechanism of the reaction thoroughly, we cannot answer. That is the next standard type of the questions you cannot answer. First of all, be clear that the methane all of a sudden will not give methyl chloride. First, the hydrogen it is lost. That means Cl2 first becomes into dot. That dot will take away the H, produces the methyl dot. The methyl dot either with the chlorine dot or with the fresh chlorine, it will react and gives the methyl chloride. In 2 places we have methyl chloride. There is a support for this reaction. How can you believe that this reaction is the absolute mechanism? Means when methane is chlorinated, see there is a chance of getting the ethane. Very small quantity of the ethane must be formed. Then we have that is the evidence for the reaction. In fact, it is also rarely recovered. When methane is chlorinated, you will get methyl chloride, but a very small quantity of ethane is also recovered. So, that shows clearly this mechanism is passing through the methyl free radical, and 2 such free radicals there is a chance. How much is not the question, whether you get ethane or not. Yes, you are going to get. Similarly, when ethane is chlorinated, ethyl free radical will come as a intermediate, that will double. Naturally, N-butane is formed. So, in the monochlorination of ethane, so N-butane will be the one of the side product with a small quantity N-butane is formed. Then we can believe yes, that mechanism is possible. So, these are all the reactions are supported based on the evidences only. So, in this reaction, intermediate is CH3 dot and we are getting the methyl chloride as a final product. The whole mechanism is called free radical substitution reaction. That means attacking species is free radical. Intermediate is also obviously free radical. It is not the intermediate, but first coming group is free radical. Therefore, it is called free radical substitution reaction. And why only free radicals? Why not electrophiles will enter? Means the alkanes are neutral. So, electrophiles and the nucleophiles are acids and bases have no chance of attacking all the alkane. Alkanes are neutral. So, the reagent also must be neutral. That is free radical is the neutral reagent. So, we have, so therefore, only the neutral that is attacking species, that is free radicals, will have a chance to attack. Therefore, and it is saturated, you cannot add. So, the only the reaction on the alkanes is free radicals will attack. Show the substitution, it cannot add, already saturated, you cannot add. So, only substitution is taking place. So, logically alkanes undergo free radical substitution, the mechanism happens to be chain reaction mechanism is taking place.